Okay, consider the equation 10z squared minus 3iz minus k equals 0. They go on to say that z is a complex variable. That means it's the form a plus bi. They go on to state that I squared is equal to minus 1. Pretty obvious. Which of the following statements is true? Again, I got to read each statement and look at the equation and see if it's true or not. Right? So what I'm going to do is go to the whiteboard, write the equation down. And the equation is stated as follows. 10z squared minus 3iz minus k equals 0. So I'm going to use quadratic formula to solve for k. And you can get 3i plus or minus, the bottom's going to be 20. Let's see, I'm using quadratic formula, so it's going to be 9i squared minus 4 times 10, and then a minus k, so I'm going to put the plus sign there. Let's put this down simplified a little bit, and then I'll look at the first statement. I'll read the first statement to you as well. This is plus or minus. This would be 40k minus 9. And what do you get up here? Over 20. So let's take a look at statement number A, and I'll read it to you. It says for all positive real numbers k. So k is a real number. I'm just reading this. And they say it's positive. All right? Now, what I want to do is I'll look at it and read the question. It says both roots are pure imaginary. Well, I'm looking at this thing and I'm going to say, well, gee, if I just took k to be 1, what would this give me? And that's a positive number, by the way. I'd get 3i plus or minus the square root of, well, that'll be 40 minus 9, which is 31. So I immediately know this is the form a plus bi. All right, the a would be, in this case over here, plus or minus the square root of 31 over 20, and the b would be plus 3i over 20. So this one's clearly false. That was easy to do. All right. Again, just make the discriminant positive. And you don't have a pure imaginary, but you have a mixture. You have a plus bi, where a is not 0. Let's go to b. And what does b say? B says for all pure imaginary numbers k. I'm sorry, I have to read it again. I'm reading the wrong one, though. For all negative real numbers k. Sorry about that. So k is real again. But in this case over here, k is less than 0. All right? K is less than 0. So I want to point out, if k is less than 0, I know the discriminant, which would be 40k minus 9. Now, if k is less than 0, this is going to be less than minus 9, right? So what do I know now? I know that that discriminant is always going to be negative. So what does that mean? I'm going to get 3i plus or minus some multiple of I, some non-zero multiple of I. And how do I know that? It would never be equal to 3i, by the way. The only be equal to 3y if k was equal to 0, and k is not 0. So this will always be some non-zero multiple of I. What does that mean? This is going to sum up to a pure imaginary number. So this one is clearly true. All right, so if I had box 1, I'd box this. If this were a competitive exam, by the way, I probably would stop here and come back to it later. And the reason for that, they did say what statements. It could be more than one. But right now, B is definitely true. A is false, by the way. Now, again, I'd look at the other ones too, by the way. And the way I'm going to do that is just read them again to you. I'm going to look at C now. And what's C going to say? C says for all pure imaginary numbers, K. So K, if it's a pure imaginary number, would be some multiple of I, where A is not equal to 0. All right? So again, I'm write the discriminant down again, but I'll write the whole thing down. So it's 3i is what z is, plus or minus. This will be 40k minus 9 over 20. Well, in this case here, I really have to think about it. I'm going to pick a nice k, a k that's easy for me to handle. By the way, I'm going to pick I. Now, if I did that, what do you get? You're going to get z equals 3i plus or minus, and this is the tough part for me. This is 20. This would be 40i minus 9. I'm going to write that so it factors. There's other ways of doing it, but I think it's probably a good idea to get that to be a perfect square. And how to get that to be a perfect square? I'm kind of looking at it, and I got to think now. I'm going to break that 9 up into two separate terms that are perfect squares. So I'm going to say 16 and 25. Let me write that down. Before I move forward, I want to make sure I said that correctly, by the way. That 16 and 25, they differ by 9. All right, that looks okay. That factors. Write this over here. And that's going to be what? Looks like 4 plus 5i squared. Let me just check this for a second. 4 times 4 is 16. 4 times 5 is 20. That would come twice. That's 40. And then you get minus 25i squared. I'm sorry, you get 25i squared, which would be minus 25. This worked out nicely. What do you get over here? 3i plus or minus. This would be 4 plus 5i. Now, looking at it, a little more extensive over here. But what do you get? You're going to get, plus or minus 4. And then plus or minus 5i plus 3i. All right, just kind of writing it over again. Let me go back and read C again. It says, for all pure imaginary numbers k, both roots are real and rational. Well, that's not a real number, by the way, because they got a complex part to it. So that's false. So C is false. Let me go to D. All right, what does D say? For all pure imaginary numbers, same example, by the way, both numbers are real and irrational. That's also false. Wouldn't circle those guys. Now, I know it's false. I got this example over here, by the way. Let's go to E. All right, E. And let's take a look at E, by the way. So E says for all complex numbers k, neither root is real. All right, this is E. I'm wondering if I'm going to box this one. By the way, there's only one answer I'm starring over here. This is the only one so far that's been true. C is false, and D is false. I'm on E. All right. Now, E is going on to say that I got a complex number. Let me make sure I'm reading it again. Complex number. And write this down. Z equals A plus BI. And again, I said for all complex numbers, neither root is real. Well, I'm going to take an example, an easy one again. And what I'm going to do is write it down. Z equals, this is going to be 3i plus or minus the square root 40k minus 9 over 20. And the easy one to take over here is where A equals B equals 0. And the reason for that, when I do that, I get 3i plus or minus the square root of minus 9. If k is 0, because you're just going to get 40 times 0 is 0, that's over 20. What do you get there? 3i plus or minus 3i over 20. And one of these roots will be real. And what would it be? It would be 3i minus 3i, which is 0. And what did they say? Neither root is real. All right, so I got one root to be real, by the way. So this one is false. All right. Now, someone says you're just doing this by doing examples. It's the way to go. It really is. All right. I found an example pretty quickly where they're going to be false. And I found an example real quickly where the other ones were false too. By the way, this is probably also something you need to think about. It's not an easy question. Thank you.